Okay, I wanted to talk to you today about solving quadratic equations by factoring. Solving equations is not something new to us. We've looked at problems like, let's say, 2x plus 6 equals 14. We've been solving things like that for a while, even ones that have more terms than that maybe we would need to combine like terms first. But in a case like this, we would say, okay, we want to isolate the x term. And so we would do that by subtracting 6 from both sides. Then we would get 2x equals 8. Again, we haven't isolated the x yet. We have that 2, so we would divide both sides by 2, and we would get x equals 4. That would be our only solution to that equation. But what we are looking at now, when we have started factoring, is we've been looking at things that are often quadratics or sometimes higher. And so maybe we would have an equation that looks like this: x squared minus 6x minus 7 equals 0. Right, again, equation. This one's a little bit different because it has more terms, because this is equal to 14, this is equal to 0. But we still are trying to solve the equation. Now there's one big difference between the two of these, and that is it's very easy to isolate the x here because nothing else contains an x in it. We have a 6, we have a 14. Here, it's going to be difficult to isolate the x because there's two terms that have an x in it. And so we need to come up with another strategy to do that. We can't use the same thing of isolating the x here when there's more than one x. And so I'm going to pause and just remind you of a thing that we talked about in class the other day, which is the zero product principle. Zero product principle. I'll lose my point there. The zero product principle says that if I have two things multiplied together and their product is 0, then the only way that can happen is if either A or B, or possibly both, is 0. But there is no way that we could have two non-zero numbers multiplied together to give us 0. Right? That is a property that is unique to 0. All right, so again, if I have two things multiplying to 0, I'm guaranteed that either A or B, or possibly both, are equal to 0. Right? But if I have something like A times B equals 1, or A times B equals 11, I have no guarantees that either A or B is going to be 1, or either A or B is going to be 11. For example, in A times B equals 1, I could have A equals 3/7 and B equals 7/3, and I'm going to multiply them together and get 1. But neither A nor B is 1. All right? And you would be hard-pressed to figure out what the numbers were if I said A times B equals 1, because it really could be anything. As long as they were reciprocals there, we're going to get a product equal to 1, but neither of them is 1. Same thing with A over B, or I'm sorry, A times B equals 11. We could do like, I don't know, let's say, gosh, it's a little bit harder here. All right, we could say that maybe we've got 2/11 times, let's say, 121 halves. That would end up giving us 11. 11 would go into that 11 times. The 2's would cancel, but neither of those factors was equal to 11. All right? So when we look at this and we say, oh, I have a product of two things equaling 0, I know things that I don't know in other equations like that. All right? And so when we solve equations like this, where we've got x squared minus 6x minus 7 equals 0, we're going to try to use that zero product principle and write this as a product of two things that equals 0, and we'll use that to our advantage to then say, well, either this is 0 or this is 0. All right, now I just want to pause for a second. We've been factoring for the last couple of weeks, and I just want to emphasize the difference between what we've been doing when we've been saying factor something like this, and now we have an equals 0, and our directions now say solve. Right? Again, just like when we were combining like terms, when we were doing linear equations, or something that had just variables but no equal sign, the best we could say is simplify. right? I can't solve unless my expression here is equal to something, right? And here, that's exactly what we have right here. So you're going to see problems that look like this, and you're going to say, oh no, do I solve or factor? If there's no equal, the best you can do is factor. With an equal, the directions automatically change to solve. Right, so just to make sure that you are paying attention to that. Do I have equal to some number or some other variable expression, in which case I could solve, or is it just a collection of terms combined here that don't equal something, in which case we just factor? Okay, so we would take a look at this and we would say, okay, I know I need to factor, so I'm going to ask about what type of factoring this is. So we always start with GCF, so do we see a common factor between those three terms? No, there's nothing. All right, next would be difference of squares. No, we've got a square, we've got a difference, but it's not two terms, we've got three terms. These things aren't perfect squares, so it's not a difference of squares. Easy general trinomial, yep, that's it. All right, easy because the leading coefficient here is 1. General because the pattern of the exponents is such that the largest one is twice the next one and the last term has no variable at all. It's definitely not a grouping because there's only 3 terms, and it's not a harder general trinomial because it's got that 1 there. All right, so then we're just going to use the rules that we talked about for easy general trinomials. We're going to split that term into 2 equal parts, x and x. Then I'm looking for 2 things that multiply to 7 that subtract to 6. All right, well, that's going to be 7 and 1. The fact that this is minus indicates that the signs are going to be opposite, one positive, one larger, and this guy gets to decide. He says that the larger one, the 7, is going to be negative. That one's going to be positive. Okay, so then we would say, all right, here's where this zero product principle comes in. I have a product of 2 things that equal 0. That means one of them has to be 0. There's no way that I can multiply 2 non-zero things together and get 0. So either x minus 7 equals 0, or x plus 1 equals 0. All right, if x minus 7 equals 0, then we would just move the 7 over and we would get x equals 7. Or if this one was the one that was 0, we're going to move the 1 over and get x equals negative 1. Now let me just pause for a second to talk about this or in mathematics, because you have had times where you've heard or, and it means you may only choose one or the other. You may either have ice cream for dessert or a piece of cake. You may not have both, all right? But or in mathematics, it means that either could be true or both could be true. Doesn't mean that you have to pick, all right? So here, all it's saying is that 7 makes this statement true, or negative 1 makes this statement true. You're not choosing which one you think is the right one. They both are right. This could be the one that works, that makes that equal to 0. This would work to make that 0. Now let's prove that that works. So we're going to go back to our original equation. So we've got x squared minus 6x minus 7 equals 0. Now when we go through the first time, x is going to equal 7 in both cases where we've written an x. We're not going to mix them up and have x equals 7 here and x equals negative 1 here. We're going to go through and show that when I put in 7 for each of these x's, I get 0. So the first says 7 squared minus 6 times 7 minus 7 should equal 0. All right, well, this is 49 minus 42 minus 7. Is that actually equal to 0? That's what it's asking us. 49 minus 42 is 7, and 7 minus 7 does equal 0. So that verifies that 7 is a solution. All right, let's do the same thing for negative 1 to verify that that's a solution. So this is saying negative 1 squared minus 6 times negative 1 minus 7, is that equal to 0? Right, negative 1 squared is 1. Here we've got a negative 6, so this is minus a negative 6 minus 7. Is that 0? Negative 1 minus a negative 6, that's negative 1 plus 6, which is 7, minus 7. Yes, that equals 0. All right, so we've got these 2 solutions that solve that equation. Again, I've written over it enough. Let me write it again here without all my handwriting. X squared minus 6x minus 7 equals 0. That was our original equation. and these two are the solutions that go along with it. All right, now you might be thinking, whoa, that's never happened to us before. When we solved linear equations like this, we only got one solution. Now here we are solving a quadratic and we get two. That is unexpected, perhaps. All right, but let's go back here. Again, last year, before we knew about exponents on variables, other than when we were just trying to simplify or multiply something out, we didn't know that there was an implied 1 there. All right, but we do know that now. Here we see this 2 right here. All right, notice that when our exponent is 1, we get one solution. Our exponent is 2, we get two solutions. All right, if our exponent is 3, which it will be when we have grouping problems, we should expect to get 3 solutions. If there are 4 exponents, we should get 4 solutions. All right, so we're going to write down something here. I want you to write it down in your notes too. The exponent, or the highest exponent, in an equation tells us how many solutions and I'm going to put a qualifier in here, real and imaginary, we should expect. All right, now let's talk about this. For right now, we only know about real numbers. You've heard about imaginary. We just kind of say that we're going to talk about them next year. But the number of solutions could be some combination of real and imaginary, and that is going to tell us, that highest exponent is going to tell us how many. Right, so here we had 2 real solutions, 7 and -1. Again, imaginary comes from taking square roots of negative numbers, which is something we're completely not ready for, but I just don't want you to be surprised that sometimes you might not get all of them, because you might have imaginary solutions. Now, because we're just learning this, you're only going to get ones where they're real, just because that would be kind of weird for you to think that, oh, I should be expecting 2 and you don't get all of them because some are imaginary. So for right now, we're only going to see ones where all of the ones that we get are real, and it will match the highest exponent. But again, next year, when we start learning about imaginary, we'll find that there are some that we'll get that are imaginary, and we combine them with the real, and that should match with the highest exponent. Okay. So then let's, I think that's all I want to say on that for right now. So I just want us to start looking at some other problems and go through this process to solve equations that involve polynomials that are higher than linear. So I gave you a sheet in class, or if I didn't, then it's linked to your assignment. So how about you get that out for right now? All right, so this is the worksheet that I'm talking about, solving quadratic equations by factoring. All right, so we are going to go through and we're going to look at 1, 3, 5. I might come back and do 2. Actually, I think I won't. I think we're going to go then down to look at 11. All right, things start to change there. And we'll also look at 16 and 19. All right, so the difference here between these, so I would say these are of the easier type, even though they're not all easy general trinomial, they're of the easier type because they're all ready for us to factor and have set equal to 0. All right, so we'll take a look at those 3 first. Then we jump down here to the bottom half, starting from 11 on down to 20, and notice how it's not equal to 0, where we have to do a little bit of work to get it so that it's that way. Again, not equal to 0, not equal to 0. So I would say that we'll start with these and then we'll see what to do when we get to a case where it's not equal to 0. All right, so for problem number 1, we're going to look at this. Again, it says solve. We're not surprised because it has an equal sign and it's set equal to something. And in this case, again, it's that desirable 0. We want it to be equal to 0 so that we can use the 0 product principle. Right, so then again, as we do with every polynomial that we look at, we say, okay, what type of factoring should I use? So first thing we check is GCF. Right, no, the 9 is promising, the x is promising, but it's not, neither the 9 nor the x is in all three terms, so it's not that. Difference of squares, again, no, you're looking for two terms separated by a minus, everything's a perfect square. It violates the two terms right there. Easy general trinomial, boom, that's it, all right? Leading coefficient is 1, it's a trinomial, and then the pattern of the exponents is such that this is double this, and this has no variable at all. Okay, so then we're going to set it up like this. All right, I'm not forgetting that 0 because I want to remember that I'm solving. All right, so I've got to find two things that multiply to x squared. Again, that's the easy part. We just split them right into two equal groups. Now I'm looking for two things that multiply to 18 that add to 9. All right, so we've got 1 and 18, 2 and 9, 3 and 6. Well, that adds to 19, that adds to 11, that adds to 9. So that's the one that we want. All right, 3 and 6. This plus sign indicates that both of them are going to be the same sign, either both positive or both negative. I can't get a positive thing without them both being the same. So then I look to this guy, and he says, oh, I can't add the two of them together and get something negative unless they're both negative. All right, now just as we did in the example that we did just a second ago, I use that zero product principle. I have two things multiplied together to give me 0. That means one of them must be 0. So either x minus 3 is 0 or x minus 6 is 0. And when I do that, I'm going to get x equals 3. Again, I'm assuming this step is going to be easy for you. You're not going to need to write anything to do that. All right, and then x equals 6. All right, let's go back to the original and check it. I'm not going to write the work just because I'm low on space here, but if we put 3 in here, we get 3 squared, which is 9. And then we got minus 9 times 3. 9 times 3 is 27. So 9 minus 27 is negative 18. Plus 18 does give us 0. So yes, that one works. And then x equals 6. 6 squared is 36. 9 times 6 is 54. So this is 36 minus 54. 36 minus 54 is negative 18. So negative 18 plus 18 is 0. I'm just checking these right now just to give you some level of confidence that what we're doing is actually working. All right. It's possible that you will make an error because you're new at this. So it's good for you to check them, but it's not like we're going to plug these in. As long as they're correct, it's going to work. Unless you make a mistake, what you get here is going to work. Okay, so then let's look at number 3. All right, so again, I have an equation. It's set equal to 0. I'm happy about that. I want it set equal to 0. So now what I have to do is just say, all right, how am I going to factor this? How am I going to get this into an a times b equals 0 so that I can set each factor equal to 0? All right, so is this a GCF? Again, I've kind of written over this to make it hard to see that. Perhaps I should just put a box around it. All right, so no GCF. Is it a difference of squares? Yes, it is. Two terms separated by a minus. Both things are squares. All right, so then I'm going to separate into two parentheses. Set equal to 0. That looks like an n to me. I think it is. All right, so we've got n and n. Then I'm going to do square root of 64 is 8. And then I've got 1 plus and 1 minus. All right, I have a product of two things equaling 0. One of them must be 0. So either n plus 8 equals 0 or n minus 8 equals 0. And if n plus 8 equals 0, then n is negative 8. And if n minus 8 equals 0, then n is 8. Again, it's not a, should I choose this one or this one? It's saying this is going to make this statement true, or if I pick 8, 8 is going to make that statement true. You don't just pick one. Both of them are solutions. That's all there is to it. Don't pick. So it's one of those. These are the two solutions that make this statement true. Okay, now we've got, for number 5, we've got 35n squared plus 22n plus 3 equals 0. Again, I'm excited about the fact that it's equal 0. I'm less excited about the fact that this is a harder general trinomial. Again, it's a trinomial. It's general because we've got an n squared, n to the first, the exponent is half that, and then there's nothing here. All right, so we're going to do our guess and check method that we were working on in class. All right, so I need something here that's going to multiply to 35n squared. So I already know it's going to be an n and an n. The question is whether it's going to be like 5 and 7, 35 and 1. That part I don't know. All right, so let's write down our choices for 35. I just said both of them, 1 and 35, or 5 and 7. Our choices for 3, because again, now I'm looking for two things that multiply to 3. We've only got 1 and 3. All right. So as we discussed in class, I generally start with the ones that are closest together. So I'm not going to pick the 35 and 1. They often make exaggerated or really large sums in the middle, and this is smaller than 35, so I don't think it's going to be that. All right, so let's try 5 and 7. All right, now I could put the 3 here and the 1 here, or I could put the 1 here and the 3 here. All right, so let's try each of them. So if I do this one, I'm going to get a 5, because again, remember our staples, we just look at these two here. So I'm going to get a 5n, and this is going to give me a 21n. When I do 5n and 21n, that's going to give me 26. That's too big. Here I'm going to do 15n and 7n. When I add 15n and 7n, that gives me 22. So this is the one that I want. All right, so I'm going to get rid of this one. All right, now, again, we knew, or maybe I didn't say this, I'm looking for two things that multiply, that when I multiply them together, they're going to give me that, well, let's say this. When I add them together, I'm going to get that 22. If I'm adding, that means the signs are both the same, either both positive or both negative. This is positive, so they must both be positive. All right, so now I have to take each factor. All right, so the 5n plus 1, and say it's possible that at some point that will be 0, or 7n plus 3 is 0. Sorry, I'm running out of room here. All right, so let's take a second, because this is definitely more difficult to solve than these two up here. So if I have 5n plus 1 equals 0, I bring the 1 over to the other side. That gives me 5n equals negative 1. And then I divide both sides by 5, and I get n equals negative 1/5. All right, let's take a look at the next one. All right, so here I have 7n plus 3 equals 0. I subtract 3 from both sides, and so I get 7n equals negative 3. Divide both sides by 7, and I get n equals negative 3/7. Okay, these are less fun to check. And I would suggest that for ones where you get a fractional answer, I'm very happy to just have you check the answer key, but let's just, for practice, check negative 1/5 in here, because it's not super difficult. So let's do it. I'm going to do it on the back though. So we've got 35n squared plus 22n plus 3 equals 0, and we got n equals negative 1/5. All right, so that's 35 negative 1/5 squared plus 22 times 1/5 plus 3 equals 0. Gross. All right, 35 times negative 1/5 times negative 1/5 is positive 1/25, plus 21 times 1/5 is 22/5, plus 3 equals 0. All right, it looks like perhaps we would benefit from getting a common denominator of 5, but I do notice that these will cancel and get us down to a 5, so let me do that. That's going to get us 7 and a 5. So this is 7/5 plus 22/5 plus 3. Whoops. This should be negative. Okay, that's better. I was going to say there's no way that's going to equal 0. All right, so 7/5 minus 22/5. What do we get? We get negative 15/5 right there, plus 3. Negative 15/5 is negative 3, plus 3 equals 0. All right, again, if you want the practice of doing that, you can. If you don't have an answer key, that's what you should do. But because you have an answer key, please, when you get a fractional answer, use your answer key to check that. Okay, so then let's go back and take a look at number 11 then. All right, again, the nice thing about 1, 3, and 5 was that they were already all set equal to 0. But when we get down to 11, 16, and 19, not so much. All right, so here, the thing that we want to do is make sure that we get everything to one side. Now, you might be looking at this and saying, oh, I'm just going to move the x squared over. But our rules for factoring rely on that leading coefficient being positive. So even though it would be faster to move the x squared over, we want to keep that positive. Right, and so I'm going to move the 11x and the negative 28 over. And so this is going to become x squared minus 11x plus 28 equals 0. And now it's just exactly the same thing that we did up top. Right, we're just going to look at that. We're going to decide what type of factoring we should use. Right, so GCF, no. Difference of squares, no. Easy general trinomial, yes. Right, so I'm looking for two things that multiply to 28 that add to 11. Right, and again, this tells me that the signs are both the same, and this tells me that they both must be negative. All right, so we're going to have x minus. All right, we've got 1 and 28. No. 2 and 14. No, that would give me 16. Or 4 and 7. Yes, that would work. So 4 and 7. Okay, this tells us that x minus 4 equals 0, or x minus 7 equals 0. All right, if x minus 4 equals 0, then that tells me x equals 4. If x minus 7 equals 0, then x equals 7. And these would be our two solutions. All right, you're welcome to check them in there. In fact, let's do that since it doesn't, since it's not in the same form as the others. So if we plug this in, we're going to get 7 squared. Let's just check this one. 7 squared, is that equal to 11 times 7 minus 28? All right, well, 7 squared is 49. Is that equal to 77 minus 28? Yeah, if I take that, 17 minus 8 is 9, and then 6 minus 2 is 4. So yes, that is true. All right, you could check the same thing for 4. Again, I encourage you to go back to the original. I'm not going to sing our song, but I encourage you to go back to the original because it's possible that you've made a mistake when you carry over your terms to the other side. Maybe you changed the signs in a way that was not appropriate. So always go back to the original to check them. Okay, let's take a look at number 16. I've got m squared equals 2m. Again, not set equal to 0, so I know I have to do something to get everything over to the other side. All right, so I'm going to subtract 2m. I get m squared minus 2m equals 0. This tends to be something that freaks people out, and I don't know exactly why. Because again, if you're just going through your list of factoring techniques, you'll find the one that you need to do. So first thing we should check is there a GCF? And yes, there is. It's an m. All right, so even though it's not a trinomial, again, it's got the beginnings of a trinomial right here. It's got the beginnings of the general part of a trinomial. It's kind of got like the m squared, it's got the minus sign, so it's got the beginnings of a difference of squares, but the only one that actually works here is a GCF. That's why I say always check for GCF first. All right, so the common factor is m, and then I'm going to be left with m minus 2 is equal to 0. Again, it's okay that this is a monomial, not a binomial. Right? Again, don't let that bother you, that that's just a monomial. Right, so now I have a product of two things. Again, one monomial, one binomial, but it's still a product of two things that equals 0. which means one of them must be 0. So either m equals 0, the first factor, or m minus 2 equals 0. Well, if it's m equals 0, then I don't really have anything to do. It's just m equals 0. Or if m minus 2 is equal to 0, then that tells me m equals 2. All right, so those would be the two things. Let's try it. If I put 0 in for both places where I see m, I get 0 squared, which is 0. Is that equal to 2 times 0? Yes, 0 equals 0. If I put 2 in, 2 squared is 4. Is that equal to 2 times 2? Yes, it is. 4 equals 4. So those are our two solutions. Okay, let's go down to number 19. All right. Okay, so again, it's not set equal to 0. If it's not set equal to 0, that's the first thing that you should do, is make sure that you get everything over to one side. So we've got 10x squared minus 26x plus 12 equals 0. All right, I'm telling you, again, go through and look at the different factoring techniques, because right now you might jump in and say, it's a harder general trinomial, but you're right, there it is, but we also have a GCF, and taking out a GCF first is going to make our life a little bit easier. It's going to reduce the number of possibilities that we have for our coefficient of our x terms and for our constant. So there are a number of different ways that you could do it. I'm going to show you, I think, 3 different ways, and I'm going to tell you which one is my preferred way to have you do it. So the first thing is, we could just say, well, everything has a 2. Let me take that out. All right, so then we've got 5x squared minus 13x plus 6 equals 0. All right, so right there, I like that better already, because I have less choices for 5. I can only have 1 and 5. Here I only have 1 and 6, or 2 and 3, versus 12 and 10 had more choices than that. All right, and so then you could factor this. And again, I think that this is going to be 5x and 2 and 3 and minus and minus. Here's my beef with doing it this way. Sometimes people say, okay, now I have a product of 3 things equaling 0. One of them has to be equal to 0, and suddenly we end up with x minus 2 equals 0, 5x minus 3 equals 0, or 2 equals 0, and people say, yeah, that's a solution. No, that's not true. All right, again, it says a product of 3 things equals 0. One of them has to be 0. It doesn't say all of them have to be 0. 2 cannot possibly be 0. So sometimes people make weird claims like that that's a solution, when really it's just saying one of them has to be 0. It's not that guy. All right, so if you are prone to making a statement like that, don't do this method. The one I would actually prefer that you would do is, and this is because it's an equal that we can do it, 10x squared minus 26x plus 12 equals 0. Remember when we're solving equations how we talked about that equality being like a balanced scale, and I have that right now. I can do the same thing to both sides without affecting the equality. So I'm going to go through and I'm going to divide every single thing by 2. Right? Again, if it was just factoring, I have to take out a GCF. But if it's equality, because there's 2 sides, I can do the same thing to both sides. So on this side, it means dividing every term by 2, and on this side, it means dividing the 0 by 2. And what that's going to do is get us right to the 5x squared minus 13x plus 6 equals 0. And that's what we want to factor, right? Again, so we just get rid of that 2 right away, and we're fine. Now, let me caution you, if there had been an x also in common for each of these, you cannot divide by x, all right? If there was an x everywhere, let's say we had 10x cubed plus, minus 26x squared plus 12x equals 0, and I divide everything out by a 2x, sorry, I might be oversharing right now. This is going to give me that 10x squared, but I was expecting 3 solutions, and in this new equation, I'm only going to get 2. Right, so dividing by a variable, not cool, because it takes away one of our solutions, so don't do that, all right? So if it's just a coefficient or a constant that we're dividing by, totally fine. If there's an x in it, don't do it. All right, so then let's go back to this. All right, so I only had choices here of 5x and x, so I'm going to erase this just so we can think it through instead of me just forcing it down your throat there. So it's got to be a 5x and an x. This has to be either a 6 and a 1 or a 3 and a 2. Again, my preference is always to start with the two that are closer together. 1 and 6 are farther apart, 2 and 3 are closer together. So I'm going to choose these first. Right? I know that they're both going to be the same and they're both minus. Right? And I'm going to choose to do the 2 here and the 3 here. Because I know that's going to give me 10 and that's going to give me 3. If I reverse them and put the 3 here, that would give me 15 and 2. And because we're adding, we would get 17, not 13. All right, so we've got this now. Again, I've eliminated that as a possibility. So I've got 5x minus 3 equals 0 or x minus 2 equals 0. This tells me x equals 2. And this tells me I'm going to add 3 and divide by 5. This tells me x equals 3/5. Sorry, this is so squishy. All right, I'm not going to check them. I'm going to let you check them. Okay, let's go back up and look at number 2, and I'm going to have you do that one on your own. So if you could just pause this for just a second, and I want you to try to factor and solve that equation. Okay, let's see how you did. All right, so we look at that and we say GCF, nope. Difference of squares, definitely not 3 terms. All right, easy general trinomial, yes. All right, I'm going to have an x and an x. I'm looking for 2 things that multiply to 4 that add to 5. Both have to be the same sign and both have to be positive. All right, I could go with 2 and 2, but that's going to add to 4, so I'm going to go with 4 and 1. Those two will add together to give me that 5x, but multiply together to give me 4. All right, so that says that x plus 4 equals 0 or x plus 1 equals 0. And then this is going to tell me x equals -4 or x equals -1. Now, at some point, you're going to ask me, do I actually have to write this step, or can I go right from here to here? And I would say, at some point, you're going to feel like you're ready to do that. So when you are, feel free to go from this to this, from this to this, instead of writing this step. I will say that for a while, probably, when you look at these, you're not going to be able to skip this step. You're going to want to write that out, and you're going to want to take the time to solve it. But again, at some point you will be ready, but for right now I would say when you get a coefficient on your variable, please write that step and please take the time to solve it algebraically. Okay, one more, and again this is going to be kind of like number 16 was. Take a second, stop the video and take a look at problem number 4 and see how you do with that. Okay, so assuming that you finished already, all right, so GCF, yes, actually. So we take out that b, we've got b plus 5 equals 0. All right, again, I know that this is just a monomial, that's okay, but it's a product of 2 things that equal 0, so one of them has to be 0. So either b equals 0 or b plus 5 equals 0. Again, this one is a freebie right here. But now this is going to tell us that the other solution is b equals -5. And again, you can substitute them back in and figure it out and show that they actually are equal. Okay, last one, take a look at number 15. And again, I want you to pause the video and see if you can do it on your own, and then come back when you're done and we'll do it together just so that you can confirm that you got it correct. Okay, so for this one, it's not set equal to 0, which means that we're going to have to move this 3x over to the other side to join the 17x. So this becomes x squared plus 14x plus 49 equals 0. Again, that comes from subtracting the 3x from the 17x. All right, so now I'm looking for, again, it's not a GCF, it's not a difference of squares, it is an easy general trinomial. All right, so that says this is going to be an x and an x. I'm looking for two things that multiply to 49 that add to 14. Both of them are the same sign, and that sign is positive. All right, two things that multiply to 49. 49 is only 1 and 49, or 7 and 7. All right, and it's going to have to be 7 and 7. 7 plus 7 do add to 14. So we've got 7 and 7. This is interesting because I've got x plus 7 equals 0 or x plus 7 equals 0. If I do that, then I say x equals negative 7 or x equals negative 7. That's weird. All right, so here's how we write it. You could say x equals negative 7 or x equals negative 7. People might say, did you just repeat yourself? Or you could write x equals negative 7, and you could say double root. All right, meaning it's this solution, but just double. It just shows up a second time. Again, the reason that you would need to write this and not just write negative 7 is because, again, we know we're expecting two solutions. If you only write x equals negative 7, somebody's going to look at that and say, you didn't give me all the solutions. All right, and so you have to either write it twice to indicate, well, it was just showed up twice, or you have to write it once but say that it was a double root, indicating that that's the reason that there isn't a second distinct number. It's just the same number double. Okay, that is all I've got for you, and we'll get to practice some of these more together in class. Bye.